Okay, so look at this question. A block A can slide on a frictionless incline of angle theta, length L, kept inside an elevator going up with uniform velocity V. Find the time taken by block to slide down the length of the incline if it is released from top of incline. Since it is going up with uniform velocity, do we need to write any pseudo force? No need to write pseudo force because it is going up with uniform velocity. So only mg and only normal, no pseudo force. If no pseudo force, the question is very simple and we know how to solve this. The acceleration in this case is how much? G sin theta. Okay, so we can directly write. I am writing it directly because we have done in the previous questions. So how do we write it? We take the x-axis like this, y-axis like this. We take mg here. This will become theta. So component of mg along x-axis, that will be mg sin theta, and that is equal to ma. So a comes out to be how much? G sin theta. So these things we have already done, and pseudo force is not applied here because lift is moving with constant velocity. Now second part, I am giving the second part of this question. If lift is accelerating up, if part B, if lift is accelerating upward, accelerating up with acceleration a, with a naught acceleration, okay, then find the time taken. So in these two cases, the first case is given in the problem itself and second case I am giving. Then find the time taken. In this case, what we have to do? So in this case, the forces will be like this. We have to write a mg, then we have to write a pseudo force ma naught, and then we have to write a normal. Okay, we have to write mg downward, then we have to write ma naught downward, and then we have to write a normal. So here, if you want to solve the equations, what it will be along x direction. If we take again, this is x and this is y. Okay, so along x, if you see along x, equation along x, if you write. So as we have written mg sin theta, we have to write mg sin theta, mg plus ma naught, both are acting along same direction. So mg plus ma naught sin theta. This will be the force along x now. Okay, that will be equal to ma acceleration, whatever acceleration we get. Okay, and one thing, see, these forces are along negative direction. So the acceleration here what got, I have just written the magnitude, but the acceleration is down the incline. So the x which we have written is up the incline. So acceleration is opposite to that direction. So I am not writing it explicitly with sign, but the acceleration is down the incline. Here also the acceleration will be down the incline. That will be g plus a naught sin theta. Okay, so in this way we can write the acceleration is g plus a naught sin theta. Now what will be the time taken? Okay, in the both cases we have to find time. So how do we find time? The length of the incline is given L, so we can write L equal to half at square. So T is 2L by A, so we can write 2L by G sin theta under root. Okay, and this side we can write L equal to half at square. So T will be equal to 2L by A under root. So it will be 2L by G plus A naught sin theta. Okay. So in this way we can find the time in two cases. Okay. So you can see in this case, again we are having G effective. This is G effective. G effective is what? G plus A naught. So instead of doing all this, we could directly replace the original equation G with G effective, and we could find the answer directly without explicitly writing the pseudo force and writing all the equations.